All right, so now let's move to the next section in our sheet, which is use balanced formula equations to describe the chemical reactions that could occur when the following solutions are mixed. So determine if the reaction would result in a precipitate, and if so, state the chemical name of the precipitate. So there's a couple of stages we need to go through for this particular question. So if we look at the first one, A, calcium chloride and potassium phosphate. We first of all need to work out the chemical formula for calcium chloride and the chemical formula for potassium phosphate. We then need to work out when those reactants react with each other, what are the products that are formed, and work out what they are in their chemical formula. We then need to balance the whole equation, and then we need to determine whether a precipitate is formed. So let's start with the chemical formulas first. So we have calcium chloride. Now this is quite an easy one. Calcium on our periodic table and chloride on our periodic table. Calcium chloride. Calcium is a 2+, chloride is a 1-. So let's go calcium 2+, and chlorine is a 1-. Now we can do our swap and drop here so that we know for every calcium we have, we also need to have 2 chlorines, or 2 chlorides in this case. And we're also going to look at potassium phosphate. So for this one, we're going to need our common anions and common cation sheet as well. Now potassium is here on the periodic table, 1+, so let's go K+. And then phosphate is on our anion sheet here, down the bottom. Phosphate is PO4 with a valency of 3-. So PO4 and 3- is the valency there. So we can do our swap and drop. So we now have potassium 3, PO4 is just a 1. So now we know that this is our calcium chloride mixing with our potassium phosphate, and that is our balanced ionic compounds for those. Now when we're working out which goes with which here, the easiest way I think is just to take the cation from the first reactant and combine that with the anion of the second reactant, and then do the reverse. The cation of the second reactant with the anion of the first reactant. So the cation, the positive, with the anion, the negative, the cation, the positive, with the anion, the negative. So it looks something like this. We're going to combine these two, and we're going to combine these two. And so that will give us calcium phosphate and potassium chloride. Good. Now we need to make sure that this part here is now balanced based on the valencies we worked out before. So I'm going to use a green pen just to highlight what I'm doing, and then we'll rewrite it so it's a bit clearer. So we know that phosphate has a valency of 3-, and calcium has a valency of 2+. So if we're going to swap and drop these, this 3 will come down here with calcium, and the phosphate, we treat the phosphate group as a whole, and we put the 2 outside those brackets. So that tells us that this PO4, we need 2 of those PO4 molecules to bond with our 3 calcium molecules to be balanced. Now we know potassium +1, chloride is -1, +1, -1, they cancel each other out. So we know that that part there is balanced. Now let's rewrite this so it's a little bit clearer. Calcium 3, brackets, PO42 plus KCl. Okay. Now we need to make sure that all of this equation is balanced. Now that we've balanced our ionic compound parts, we need to make sure the whole thing is balanced, meaning that for every calcium atom is on this side, we need to make sure there's the same number of calcium atoms on that side, the same number of chlorine atoms on this side with the same number of chlorine atoms on that side. So the same number of atoms within the reactants need to equal the same number of atoms within the products, which is the law of conservation of mass. So let's do it this way. Ca equals, Cl equals, K equals, and we'll treat the phosphate group as a whole, equals, and we'll do the same on this side. And this is going to help us keep tally of what we're balancing here. All right, let's use the red pen to make this nice and clear. Let's start with calcium. Just because it's the first one, I don't know which one's going to be the easiest one to balance, but let's start with calcium because that's the first one. So 1 calcium here and 3 calciums there. So that means we need to have 3 calciums from this side in order to produce our 3 calciums on that side. Now the easiest way to do that is probably to put a 3 in front of that whole calcium chloride. So now I've got 3 calciums and 3 calciums. So let's go ahead and put a 3 in here and a 3 in there. Now because we've now got 3 molecules of calcium chloride to give us the 3 calciums we need in the products, we need to now make sure that we have the same number of chlorines. So 3 times 2 gives us 6 chlorines, and on this side we only have 1 chlorine. So 6 on this side, 1 on that side. Let's put a 6 in front here. So now we've got 6 chlorines here and 6 chlorines here. And we can put a 6 down here. So we know that the chlorines, at least at the moment, are balanced. Now because we've got a 6 over here, we've got now 6 potassiums that are being produced, or 6 potassium atoms that need to come from the reactants. When we look back on this side, we've only got 3 potassium atoms to use. So law of conservation of mass, the potassium numbers here need to match the potassium numbers there. So we need to times something by 3 to give us 6, which is 2. So now we have 2 lots of 3 potassiums, 6, which produces the 6 potassiums there. Now, by putting the 2 there, we've also now said we've got 2 phosphates. So 2 molecules of potassium phosphate means we have 6 atoms of potassium and 2 atoms or molecules of phosphate. Now when we come over on this side, we notice in our PO4 we already have 2 because we need that to balance that ionic compound. So we can say that that is 2 and that is 2. And that tells us now that this reaction here is balanced. So if we now, I'll just get a new page here. If I now rewrite that in a way that's going to make it a bit easier, we're going to have 3CaCl2 plus 2K3PO4 produces Ca3 and in brackets PO42 and 6 KCl. So that now is our balanced equation from when we react calcium chloride with potassium phosphate. Now this one is one of the more difficult ones that you'll face. There's a lot that needs to be done to balance this. So if you can work out this, if you can take it from our original calcium chloride plus potassium phosphate and turn it into this, then you're doing really well with your balancing of chemical equations. So that's our balance formula. Now the question asked to first of all balance the formula and then determine if a precipitate was formed. So yes, no for a precipitate, and then to write down the chemical name. So let's get our solubility table back out. And these are the products. These are the ones we need to determine if a precipitate was formed or not. So let's look at phosphate first of all. Phosphate, PO4. And in this case, it's calcium phosphate. So we look at the top line here, we're looking for Ca. Ca, there's no Ca there. These are all the phosphates that are soluble, which means calcium falls in the all others, which would mean that calcium phosphate, in this case, has a low solubility or is insoluble. So the precipitate forms with calcium phosphate. Let's just check the chloride though, just to make sure. Chlorides, we've got Ag, Pb, Hg and copper, so silver, lead, mercury and copper. They're the low solubility, or they're insoluble, the precipitate ones. Now that tells us potassium doesn't fall in that list. So potassium falls in the all others, which is soluble. So we know that that then is soluble. So is a precipitate formed? Yes, a precipitate is formed. And the precipitate formed is our calcium phosphate. All right, so you should now have enough information to be able to go and do the rest of the questions on that sheet. So I want you to have a go at those, and if any of them really trouble you, come and see me in class. But I think we've done a pretty hard one to start with, and if you can get that one down, you should find these other ones a little bit easier.